Example 2. Finding a limit as x approaches infinity. In the previous examples, we looked at how to graphically determine what the limit as x approaches infinity and negative infinity was. In this example, we're going to look at how to do that algebraically. However, it also does help to determine the graph graphically in order just to get an idea of what we're looking at. So in example 2, we're going to find the limit as x approaches infinity of sine of x over x graphically and then confirm it by using the squeeze theorem. So if we graph this on our calculator, we're going to get a graph that looks like this. Now just looking by this window, we can see that as x approaches infinity, or as x gets increasingly large, we see that it approaches 0. So I'm going to change the window so that we go from negative 1,000, or we'll do 100, to positive 100. And I'm going to make my y scale go from just negative 1 to 1. And as you can see right here, the blue dot is insanely close to the x-axis, and then it spikes, and then it goes off to the x-axis pretty quickly. Using a computer-generated picture, I can see this is what the graph looks like. And I can see as x approaches infinity, I can see the graph start to also approach 0. So as x approaches infinity, y is approaching 0. Now we're going to prove this using the squeeze theorem. So we want to prove that the limit as x approaches infinity of sine of x divided by x is equal to 0. So when we use the squeeze theorem, the first thing that we do is bound it between two numbers. So I'm going to say that sine of x is bounded between negative 1 and 1. Now the next thing I need to do is make these functions match. So I'm trying to make this function match this function. So to do that, I need to divide everything by x. And so I get that negative 1 over x is less than or equal to sine of x divided by x, which is less than or equal to 1 over x. And now what I'm going to do is I'm going to take the limits of each piece. So the limit as x approaches infinity of negative 1 over x is less than or equal to the limit as x approaches infinity of sine of x divided by x, which is less than or equal to the limit as x approaches infinity of 1 over x. So the limit as x approaches infinity of negative 1 over x is 0. And this is because the denominator is getting increasingly large. So we get closer to like 1 over 1,000, 1 over 10,000, 1 over 10 million, which is basically 0. So then we get 0 is less than or equal to the limit as x approaches infinity of sine of x divided by x, which is less than or equal to, and again this limit goes to 0. So it's less than or equal to 0. And so now we're done. We just have to write our conclusion. So therefore, since the limit as x approaches infinity of negative 1 over x equals 0, and the limit as x approaches infinity of 1 over x is equal to 0, and negative 1 over x is less than or equal to sine of x divided by x, which is less than or equal to 1 over x, then by the squeeze theorem, the limit as x approaches infinity of sine of x divided by x is equal to 0. And so algebraically now we're able to prove that the limit as x approaches infinity of sine of x divided by x is equal to 0 instead of just having to refer to a graph. So now what I want you to do is to try this problem on your own. The limit as x goes to infinity of 1 minus cosine of x divided by x. And I want you to determine the limit and then use the squeeze theorem to prove it true. So go ahead right now, pause the video, and try that out. Step 1 will be to graph, and then step 2 is to use the squeeze theorem. And so when you graph that on your calculator, you're going to see something like this. And so as you go to infinity, you're going to see this thing start to taper off to 0. So analytically, we're going to use the squeeze theorem. And typically when I start a proof, I'm going to write what I want to show. So this is WTS, want to show that the limit as x approaches infinity of 1 minus cosine of x divided by x is equal to 0. And so here we go. We're just going to use our mathematics and we're going to write it and solve it. Now that we have that algebra out of the way, we're going to get that, therefore, since the limit as x approaches infinity of 0 is equal to 0, and the limit as x approaches infinity of 2 over x is equal to 0, and since 0 is less than or equal to 1 minus cosine of x divided by x, which is less than or equal to 2 over x, then by the squeeze theorem, we get that the limit as x approaches infinity of 1 minus cosine of x all divided by x is equal to 0.